Hi, and welcome back to Mr. Haas's Help videos. Okay, we've got one here that's a little bit different. This is not something that we would have in our Big 15 problems. First one we're going to look at for Chapter 11 or Lesson 11 is GCF, Greatest Common Factor. And a factor are those numbers we multiply together to get bigger numbers. Example, so if I had the number, let's say 12, well, the factors of 12 would be numbers like 1 and 12. You multiply those together to get 12. Another set of factors would be 2 and 6. And another pair would be 3 and 4. So these would be all the factors of the number 12. Now we're looking for the greatest common factor. Well, let's choose another. What we're going to use here every time we look for the greatest common factor is when we're comparing factors of two different numbers. Let me just take an easy one here. I'm going to go with 9. Okay, so the factors of 9 are 1 and 9. Easy ones. We also have 3. Well, that's it, 3 times 3. There are no other factors then. So what is the biggest or greatest common, in other words, that's in both of these lines, factor? One of these numbers. So the biggest one that's in both lines that's a factor, since these are all factors. Well, that would be 3 right here. It is the biggest number that's in both. Yes, they both have 1. Fine. Okay. That's it. That's how we get greatest common factor. Now, when we would use this would be a situation where we're looking at a problem that they want to know, how we could find something like, piece of ribbon, let's say. This is kind of like a twist a little bit on a problem. So let's say that we had someone who wanted to put a piece of ribbon on each package. They only had so much ribbon they couldn't wrap the whole package. So what they've got is they've got 2 pieces of ribbon. One of them is 24 inches and the other piece of ribbon is 40 inches long. And they're thinking, all right, well, how many equal pieces, in other words, pieces of the same size, can I get out of these 2 pieces? Now that's kind of hard, you know. You might want to try folding it and cutting it, but that might not always work out right. So it's better to kind of come up with the number in advance and try and make your cuts nice and clean. So, but let's use the math. Let's use greatest common factor to figure this out. So the factors for 24 are 1 and 24, and 2 and 12, and 3 and 8, and 4 and 6. You'll notice how I'm trying to keep these all in order. I start off with 1 and its factor pair, 2 and its factor pair, 3 and its factor pair, 4 and its factor pair. You'll notice that's about as far as I can go. Sometimes you're going to have gaps in here. You're going to have numbers that you're not going to be able to fill in. Well, if there's no factor for 5 and we already have 6 and there's nothing for 7, so let's try 40 and see what we get. So if we have 1 and 40, 2 and 20, 3, no, 3 doesn't work, so we don't have a factor for 3. 4, yeah, 10. 5, yep, 5 times 8. 6, nope. 7, nope. All right, so let's look at these 2 lines and see what the biggest number is. Let's see, I have an 8 here and I've got an 8 over here. So my greatest common factor between these 2 lines would be 8. So if we go back to our problem of how many ribbons can they make out of these 2, well, they could make 8 of them. They're going to get 3 here, and they're going to get 5 here. Okay, and it turns out that they're going to be, let's see, only 8 inches long, right? All right, very good. So that's how you do greatest common factor. Want to try one more? let's see. That would be, well, we've got this thing they're going to throw at you. It's kind of a funky thing, but I know where they're going with it, why they're trying to get you to do this. They want you to use the greatest common factor and the distributive property. And the reason they are doing this is it gets to algebra. When you start getting into algebra, they want you to be able to do what's called factoring out. You'll have two big numbers, and they want you to get it down to smaller numbers. In other words, they want you to find out what do they have in common. Sometimes it'll be when you're using, letters and things like that, and they want to get all the letters out and find out what the smallest that you can get. Well, let me give you an example here. So they're going to give you two numbers. And let's say our numbers in this case are 24 and 18. And they say, all right, use that greatest common factor and the distributive property. All right, so first of all, what you got to do is you got to find the factors, the common factors, or the greatest common factor in this case. So our common factors for 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. For 18, it's 1 and 18, 2 and 9, 3 and 6. That's it. All right, so what is the greatest common number in all these? Let's see. 6. There's our 6 right there. Okay, so this means I can take a 6 away from each of these. And what they want you to do is they want you to write a 6, because we're going to pull 6 away from each. And we're going to put the other factor inside of parentheses, like this. Now for the 24, 6 is a factor pair with 4. So I'm going to put the 4 here, and I'm going to put a plus here. And the factor pair for 6 in the number 18 is 3. So what you've done is you've used the distributive property to pull the factor of 6 out of each of these numbers. This is what they have in common. And pull it out, and then you've got 3 and 4. So that would be the common factor, greatest common factor and distributive property. Okay? We'll work more on these later. Hang in there. See you soon.